Hello, folks. I'm your host, Sukriti. Thank you so much for tuning in to the Tech Geek podcast. Guys, in this episode, we are going to talk about how automated software, is presenting an opportunity of a lifetime for techies. Now, the automotive industry is experiencing a rapid transition, such as the shift of case that is connected autonomous, shared, and electric devices. Electric vehicles, new advanced driver assistance systems, software defined cars, and new in vehicle displays are the main factors taking the driver experience to the next level. Now, this is driving up demand for professionals with expertise in, mechatronics, Autosar, battery management, AI and ML, robotics programming, and product design and development. This growing need in the automotive industry is proving to be a windfall for the IT workers. Now, to know more about these growing needs and a lot more around these areas, I'm in conversation with Omkar Panse, who is the Vice President, Head of Software Defined Vehicle Middleware Solutions at KPIT. Welcome to the show, Omkar. I'm so delighted to have you here on the show with me.
Thank you, Sukriti. Pleasure to be here.
Okay, so Omkar, this is a very interesting, aspect of conversation that we've picked up today. For our readers here who will be listening to us, who will be reading the articles, and who are very keen to know how it's actually developing as a career opportunity in the coming time for them. So, without any further ado, let's start with the very primary and the very basic knowledge that how this paradigm shift in the automotive industry has happened over the years. Could you please help us understand that?
Sure, absolutely. And thanks once again. I think it's a very exciting topic. If you look at the automotive industry and take a kind of a quick recap of the last 100 odd years, we started with the first industrial scale manufactured car, which was Ford Model T, right, back then. And it basically was a typical what we call as an internal combustion engine, where you are injecting fuel, you ignite the fuel, the fuel burns, and that creates the thermal energy, pushes the piston, and then you convert that into basically a motion, kinetic energy, and the vehicle moves ahead, right? So it was an elegant system at that point in time, and obviously kind of a completely breakout of the means of mobility at that point in time. Nonetheless, it was just the first step. It was just one of the early steps, right? And ever since then, we have looked at cars or anything which is about personal mobility through a completely different perspective. Basically, how do you get from point A to point B? And of course, what started as a means of getting from point A to point B faster, maybe safer, it was by no means still very cheap, and it was not clean, and obviously people kept at it. How do you now make it more fuel efficient? How do you make it cleaner? How do you make it faster? How do you make it more powerful? How do you make it more comfortable? There are so many adjectives that kind of keep to my mind, come to my mind. And of course, then we had nice cars with a lot of chrome and leather and wood and whatnot inside it, powerful engines, which make nice purring noise and whatnot. And it kind of characterized and symbolized a certain type of not only just a lifestyle, but kind of a powerful gadget that you're kind of owning, and it kind of therefore became a critical part of our lives, so to speak. And same thing was simultaneously happening on to the two-wheeler side and the commercial vehicles. Of course, commercial vehicle had their own utility to transport the goods, but then along came a point that the efficiency gain was not enough, because these were largely mechanical systems, right? The time when you inject the fuel, the time when you ignite the fuel, how do you kind of synchronize all of that? It was largely mechanical systems, and they reach their limits, so to speak. And the safety standards kept on growing. Obviously, eventually the emission standards caught up, and we reached a point that the mechanical systems were no more adequate to provide the required level of safety, required level of efficiency, and required level of compliance to the emission norms. Alongside, the microprocessors and the whole electronic industry was advancing, right? We had 4-bit microcontroller back in probably 70s, 60s, and 70s, but the Moore's law caught up, and now we have microprocessors, very powerful microprocessors which have trillions of transistors on them, right? So the advancement of electronics and the software, it kind of had an intersection with automotive with what we call as a control system. So control system is nothing but you kind of send some parameters, you send some data, you have a control logic loop acting on it, and then you drive some decisions, what is called as an actuations. So control, a control loop, data sensing, control loop, and actuation, and that triggered a kind of created an explosion of the features that you see in the cars today. Starting from electronically injected fuel to what is called as an ABS. All of you would have heard of those terms as you are buyers of cars and motorcycles today. But it also kind of led to how do you make it more comfortable? How do you entertain the people inside the car? So obviously then came radios. Then how do you put radios inside the car? How do you put cassette player, then CDs, and then USBs? And today we are in the world. How do I stream music right inside my car? And today's state of the technology now allows us to use my Spotify subscription inside the car, listen to the same songs that I listen to home, talk to the car using voice prompts the way you would probably do at your home. You have a nice 10-inch screen, you can watch videos. We are also now already looking at in-car gaming and whatnot. And also other advancement like autonomous driving, right? So how do you make cars safer? How do you make the overall situation on the road safer? And obviously that has been made possible by advancement in machine learning and neural networks and whatnot. So if you see the cars today, I think it's a confluence of so many different things. Already the car was a complex machine. As an engineer, and I am a mechanical engineer, so for me it was a fascinating thing that how can a device like a car combine all the disciplines like mechanical engineering, electrical engineering, metallurgical engineering, chemical engineering, you name a discipline and it's there, right? And it was already there. And to add to that, we have software, and the software is expanding to take all those streams, which I'll talk about in a few moments to put it in perspective. But that's where we are. So what started as looking back as a dirty fuel guzzler that could probably move at not so much speed, polluted a lot, to today's state of the art modern car, which is driving by itself, which is running on electrical batteries, what we call as a battery electric vehicle, can keep us connected and entertained like nothing. And then we are looking at the next horizon from where we stand. So it's an exciting journey. So
this is like walking down the memory lane of the entire shift that has happened, the kind of changes that we have seen over the years.
Yeah.
Moving on to the next one, Omkar, how can these techies that we actually spoke about in the beginning, we set up a little pretext of how they're looking at new opportunities. Now, how can these techies build resilience in their careers by building strong competencies here?
Yeah, absolutely. Great question. So as I said, for me, when I looked at the when I first looked at an engine, as I said, I was fascinated, and it kind of symbolized a confluence of so many different things, so many engineering disciplines coming together. If you look at the car today, as I said, the same thing is happening purely from a software as a technology perspective. In the earlier days, most of the car software was confined or limited to what is called as a control system software. So all you had probably 8-bit microcontroller, 16-bit microcontroller, 128 kilobyte memory was a luxury, and you put a tiny bit of software that did engine control or emission control, and that was pretty much about it, right? But today, like the engineering disciplines, if you look at software alone, we are looking at a confluence of a varied set of technologies. We still have deeply embedded control system software at one end of the spectrum, where you mostly are programming in C, maybe occasionally in assembly if you're doing a very, very low level software, to all the way to what can I do with generative AI technologies like ChatGPT? How do I blur the boundaries between the car and the cloud? How do I bring containers, Dockers inside the car? How do I build smartphone applications that seamlessly connect with the car? So the point is, there is not a single technology that is not touching the cars today. We are looking at control system engineers. We are looking at embedded software engineers. We are looking at somebody who can write complex object-oriented software, C++. There are pockets in the car software. We are already talking about Rust. Probably Rust is a language we are still not even looking at, maybe during your college days, but that is kind of already catching up. We're talking about Dockers, we're talking about containers, we're talking about operating systems like Linux, how do you intimately integrate that with the hardware. We are talking about how do you deploy neural network models for autonomous cars inside the car. We are talking about scalable backend cloud platform for topics like connected software, remote software updates, things like that. So as a techie, I think uh, today we are looking at a scenario that you can pick and choose any of the area and still kind of grow into that, but of course there are some elements which are at the forefront of it. For example, the basic understanding of the technology, the first and foremost, probably even before that, the passion for technology and the problem solving, and then the technology or the language itself is secondary. So for me, to kind of, if you were to kind of looking at to build a competence in this, to build an edge, is the curiosity and that passion for technology and problem solving, and then ability to kind of learn to look at, hey, the technology doesn't matter. For example, today we are already staring at future where potentially good deal of work could be done by ChatGPT, but then how do you use something like ChatGPT or generative AI effectively, right? That is on one hand side, but all the existing skills and tech abilities that you have are still extremely critical, because one thing that underlines the software in the car is what is called as it is safety critical. You cannot have car run off the road or run into somebody or hit a wall just because of a software bug, right? It's okay if a smartphone application crashes, but it's not okay if something in the software in the car crashes. So how do you write that software? So there are all those relevant skills and competency areas which kind of come relevant. And of course, as I said, then how do you put it all together in a given set of resources in the given context so that it is usable, it is maintainable, and it is safe to use, of course, at the end of the day. So for me, I think, I remember when I started working, and there used to be kind of a placard on the wall. It said something like this, the uh, only sustainable competitive advantage is the ability to learn faster. So I would, as I said, curiosity, problem solving, and ability to learn faster, I would put a premium on that. But of course, then whatever the tech skill you are, as I said, that tech skill is valuable and relevant. And then there are intersecting paths in which you can grow the competence to look at the next level of career.
Okay, so Omkar, this was particularly about technologies. You've already named a few, but if you could just help us understand, what are some of the new age mobility technologies that have emerged in the recent years? Because I think this is very much related to building a strong competency when it comes to looking at the career opportunities.
Absolutely, yeah. So if you look at the new age technologies, as I said, car is a confluence of many of those. And just to put the spectrum broad in terms of building the competence, as I said, if you're a control systems engineer, we are no more talking about hand coding. Gone are those days, right? Nobody writes the control system software handwritten. We are looking at already model-based development. So how do you think in models? How do you do model-based development is a critical competence. And the technologies like, there are tools like MathWorks, MATLAB Simulink from MathWorks, and there are UML modeling tools. There are advanced state machine modeling tools. So in general, model-based development becomes a critical competence, and it is, typically the control system engineers, thrive on that. So some of you who are probably already in that area, I'm pretty sure you would have already used model-based development during your days, during your, education days, and you'll find that extremely relevant. Um, uh, Object-oriented thinking and programming, I would kind of single that out as one of the critical competency, because it teaches you how do you decompose the problem, how do you break down things, and how do you structure your software system. It's very, very critical. I'm deliberately not calling it as C++ or Java, because for me that is a language that you can pick up. But the fundamental thinking in your mind, as are you able to think in an object-oriented manner and break down a software system, is a critical competence. And it's extremely valuable and relevant. But taking it to the new age now, I think, as I said, we are now already looking at cloud computing technologies intersecting with automotive. We are talking about containerization technologies like Dockers. Why do you use Dockers? How do you create Dockers? How do you deploy Dockers? How do you organize your system in Dockers? coming to think of it, therefore the microservices based architecture. How do you create a system based on microservices, and how do you put it all together? Of course, some of these are still very dominant on the cloud side, but as I said, today cloud is an integral part of the car. Gone are the days where you had a car on one side, then you have some telematics device which sends the data and something happens. No, we are already looking at car as a or cloud as a seamless extension of the car, and therefore the cloud technologies, all that I mentioned, are very, very relevant. All the cloud programming languages like Python, Java, very, very relevant. But then things are going beyond that. We are, as I said, we are already looking at new programming language like Rust. Rust is very, very interesting to develop a safety relevant system. It's an extremely powerful language in safety aspects compared to, let's say, something like C++, getting a lot of traction. Python, as ever, very, very popular from rapid prototyping to deployment. Then there are extensions of Python like, we are looking at something like Python, we are looking at Golang, etc. So all the set of cloud technologies which are already cutting edge that you're looking at are very relevant. From a mobile phone perspective, fundamentally Android, Android is pervasive, in the sense Android is there on the phones, Android is also there inside the car all the way. So how do you develop applications on top of Android is relevant not only for mobile phones now, but also relevant for cars. And then there are underpinning technologies like communication protocols. How do two systems talk to each other? Distributed architectures, but those are like more broad and fundamental aspects of technology, right? But all these new age aspects. So if you think you are let's say a data scientist, for example, is automotive a place for you? Absolutely, because all the predictive maintenance is going to happen based on that. What it means is, today the software is predicting that a certain part in the car is going to fail maybe in another 15,000 kilometers or maybe few hours and needs a replacement, instead of waiting it out. So how do you optimize for a fleet, right? That's not going to be possible if you're not a good data scientist, if you don't understand data science aspects, if you don't understand how do you organize the data, how do you process the data, how do you visualize the data, and all the extensions of that in terms of not just data science, but obviously the machine learning. So all these new edge technologies are all the more crucial and all the more relevant, because as I said, the cars are going to be software driven, and the new features that OEMs are looking to push to the car are increasingly going to be data driven. So how do you make sense of data? How do you put it all together? How do you make it deployable? How do you make it remotely updatable? All these new technologies and aspects are becoming all the more critical.
Okay, so Omkar, we've mentioned the technologies, we've spoken about, building a strong career. And, as you mentioned, we've witnessed a lot of change in the industry over the years. And I'm sure this directly has an impact on the kind of job roles and the kind of designations that have evolved, right? So how will these job roles further evolve as auto tech will soon become one of the most sought after careers in the IT?
Yeah, thanks for that. I think maybe I can kind of call out my example over here. I joined KPIT way back in 1999. It's about almost 24 years now. From a typical software perspective, it looks like, what am I still doing here? But here is an interesting part. When I look at myself, I started as a software developer. And today I'm playing a role of vice president of one of the critical groups inside KPIT, responsible for what is called as a middleware software. Here is, and therefore, an interesting part. If you are a techie, there is no limit. Compared to, let's say, if you're doing a typical IT career, typical, let's say, mobile software career, beyond a point, it kind of gets into more managerial roles. And of course, those are very critical. It's just that what a personal flavor is and the liking is, right? So speaking of technical role, if I look at myself, it goes all the way to the top. So you're looking at yourself as a developer, but then rapidly, for example, if you look at KPIT, we kind of look at people, we seek out people who are fast learners, who have the adaptability and who have that passion. they quickly move to what we call as a tech lead, and then tech lead is a go-to guy for all problem solving in the software, in his module or her module. And then obviously then you grow into an architect. Architect is somebody who has a basic ability of bringing clarity where there is chaos. Can I move from ambiguity to clarity? That's a hallmark of architect. And obviously that's one of the most critical role that one can grow into. Eventually then you grow into what is called as a subject matter expert, and as the name suggests, you are really that. You are a subject matter expert in a given topic, in a given area, in a given domain, and therefore you are a go-to person for all internal teams. You are a go-to person for the customer. Everybody looks to you to provide clarity and kind of move the needle, so to speak. And then from there on, you kind of become maybe a principal architect, and then you kind of grow into a techno managerial role. And inside KPIT, for example, we have path defined all the way to the CTO track, or you could go into a program management track where you kind of branch out as a scrum master. And obviously we embraced agile. We are a fully agile organization. So you could grow into a scrum master. You can if you know safe agile, then you go into those roles, right, all the way up to what we call as a program management, and eventually a broad delivery management role where you're responsible for a large set of people, large projects, so to speak. Or you could be growing into what is on a product management track, right? You could say that, hey, I understand this, I'm really good at specifying what needs to be done. Then you can grow into a product owner, eventually product management. We also have very exciting opportunities from an automotive software perspective now for user experience, because in the earlier cars you had knobs and handles and buttons. In the modern cars you have touch screens, you have voice, and you have gestures. So how do you make the most of that touch screen? How do you use your voice to interact with the car? These are all user experience elements. So you can be a user experience professional. In the earlier days, the user experience was largely limited to industrial design, the color, the material, the how does the leather feel, etc. But that has gone way beyond. So all the aspects of modern product development, the human interface, human computer interface design, and overall user experience design are very relevant and probably all the more critical in a modern car. So that's something, therefore, one could grow as a UX professional all the way up to a chief of user experience office, so to speak. So these are the various avenues, and as I said, you pick a path, you pick a stream, and the confluence of technology and the automotive kind of gives you a path all the way to the top. And I don't see that to be a time limit. And in fact, at KPIT, we also have created what we call as individual contributors. For example, there are many people who want to be hands-on, who are really good at what they do, but they don't want to be managing people. They want to be individual contributors. No problem. That's also completely possible. You can be an individual contributor as product owner, as an architect, as an engineer, or as an UX expert.
Okay, so Omkar, in order to have these career opportunities that we've just, talked about, and the roles that you've mentioned that will be evolving in the coming time, there would be, certain set of skills and, some requirements that the industry would have in demand for, right, to create such a workforce. Now, what are these niche skills, that we're looking at, and the core domain skill sets that will be required to build such a workforce that actually adopts and tries and works the best possible manner to develop such devices, in the coming time?
Mhm. Absolutely. I think the domain skills and so what we look at it in two dimensions, right? And I'm not talking of a third, because third is more like a soft or the behavioral skill. So let's keep that aside for a moment. But there are hard technical skills, and then there are domain skills. Typically, when you start off with technical skills as your edge, right? And then we are talking about the basics of programming, what I call as a program design. And again, this is not a language skill, it's a program design as a structured thinking skill. So do you have the basic analytical and structured thinking skills? That's a fundamental skill. Then we're looking at specific language skills, right? And as I said, as a control system engineer, model-based development, as an embedded software engineer, C++ becomes critical. For modern complex systems, the canvas is very large in terms of C++ and Java as object-oriented programming skills. we are talking about all the cloud skills which are very critical and relevant over here. So languages like Python, I think today it's an absolute must have. You have to be able to program in Python. You have to be able to express what you're trying to do in Python, at least for rapid prototyping, and take it from there. Obviously, then there are certain advanced skills which are kicking, like, how do you think in terms of models, like, something like UML, can you break down and express your design in a modeling language like UML, so that people can understand it, you can comprehend the behavior and the structure of the system, so on and so forth. And taking it all the way to the other extreme, I also talked about the user experience. So those are different set of skills, like, for example, wireframing. How do you do user research? There's a, you would have sure heard about a term called as design thinking. So it becomes one of the key attributes, right? If you want to grow into that track, how do you do design thinking? How do you do wireframing, graphics design, etc.? And of the current days, I think the decomposition of a problem and framing the problem is very important, because if you're able to decompose and frame a problem, then you can be really good with technologies like generative AI. You can be really good with technologies like ChatGPT. Otherwise, it actually could become a disadvantage. So that's kind of a new skill that is emerging, I would say. And then from a domain perspective, you pick up the domain as you kind of take a dive into it, right? For example, one of the domain area could be, what is this all about engine software, right? And how do I control engine? What is this all about batteries, and what is this all about electric motors, and all that kind of stuff. Also, let's say, if you look at other domain areas like autonomous driving, it's a different domain skill. So domain skill is something you pick up, and therefore what we have done at KPIT, we have what is called as a practice structure. So you kind of grow into a domain as you do more and more and work in that domain. So you move the roles upwards, but you kind of move also deeper and deeper into the domain, because that's something, it's little important. It's important and something you pick up on the job. But what we are also doing is we are also working with a lot of academia to look at which automotive relevant subjects can be introduced early on. For example, one of the fundamental aspects is control systems design, but also other aspects like, let's say, Linux programming, other aspects like, let's say, connectivity software, networking, Ethernet, etc. So these are some different topics, but then you pick up the domains skills like, autonomous driving, or infotainment, or electric powertrain, or conventional powertrain, or diagnostics, operating systems, etc., as you kind of go along.
All right. Now, Omkar, I'm going to ask you one of the most important questions that almost every day everybody's talking about. India being hub for a lot of automation driving and a lot of technological advancement that we are looking at. Why do you think India is being seen as a global hub for auto tech software development now?
I think there are two dimensions to it. If you look at the hardcore, just from the vehicle perspective, right? If you look at India today, let me give an example. For example, from a two-wheelers perspective, right? So India sells highest number of two-wheelers in the world, and it's not surprising, but just kind of a data point, right? So number of two-wheelers sold in India are globally the largest. That kind of makes itself as a hub, so to speak. Just from a pure play, from a consumer perspective. But if you keep that part aside, there are a lot of other aspects that now India is looking at. We are kind of talking about the whole push towards electrification. Even by policy, Indian government is encouraging a lot in terms of the electrification, or the electric vehicle, so to speak. If you may or may not know, but in 2022 we surpassed Japan to become the world's third largest auto market, and that's something substantial, in terms of gross sales, so to speak. And also we're kind of looking at the electrification or the electric vehicles as an industry overall, as a net job creator. We're probably looking at something like adding almost something like 10 million jobs by 2030. and maybe those many large number of indirect jobs. So if you look at the tech sector, first of all, we are a very strong tech place, right? India, I mean, India and software, excuse me, is anonymous. And then you just add a layer on top of it in terms of automotive software. So one, we are a large market. Second, we understand software really well and we are the backbone for the world. And third, we have our own push for the electrification. So that kind of makes us a tech hub. And obviously, therefore, deliver the software obviously for the Indian consumers, the Indian customers, but deliver the software for all the global players of the world. For example, if you look at us, we work with who's and who's of auto manufacturers in the world. So that puts us in a unique position. So already established strong base as a software hub, a very potent local market, a strong policy push for electrification, and obviously the net talent pool that we have here from the engineering perspective. I think that puts it in a sweet spot to kind of be in a pole position even for the automotive software, which I think we are already kind of getting there, in terms of the customers we are serving globally, the kind of software we are tackling globally, and not just India, right? If you scan the scene globally, we interact with a lot of leading companies globally, whether it is a chip maker, whether it is a cloud company, whether it is an auto manufacturer. We interact with a lot of that, right? And we see that we run into a lot of obviously Indian expats over there also. So there's a lot of give and take, but I think that kind of net puts us in a very strong position to be kind of a launchpad for the next generation automotive software.
Wonderful. I think, Omkar, you've given us fantastic insights of how the automotive industry is going to fare when it comes to giving opportunities to all the techies around in the coming time. Thank you so much for sharing these wonderful insights with us in this conversation, Omkar.
Thank you so much. Once again, it was a pleasure interacting with you and all the audience. Thanks for your time. As I said, it's an exciting time, and I think we are just at the right time, right place from a software and car intersection perspective. So all the best.
Thank you, Omkar, once again. Folks, that was the Vice President, Head of Software Defined Vehicle Middleware Solutions from KPIT, Mr. Omkar Panse, in conversation with me for how does the automotive software present an opportunity of a lifetime for you techies. Thank you so much for tuning in. I hope you've your set of learnings defined today with this conversation. I will be back with some more tech podcasts very soon. You stay tuned to TechGeek for all the latest tech updates. Till then, stay safe and take care. Thank you so much once again, everyone.